Hello guys, I'm Atulesh Sharma. I'm pursuing computer science engineering in Bennett University. I'm a BTech third year student. Here in this video, I'll be delivering a presentation on optical fiber. So let's discuss the brief flow of our presentation. So firstly, we will discuss introduction, then we will head on what are optical fibers, then its structure, then the characteristics of optical fiber, then its advantages, disadvantages, working principle. At last, we will discuss what is optical fiber communication. So let's start with the introduction. So what is optical fiber? Fiber optics or optical fiber refers to the medium and the technology associated with the transmission of information as light impulses along a glass or plastic wire or fiber. So basically, it is a long fiber which is usually made of plastic or glass. Metal wires are preferred for transmission in optical fiber communication as signal travels with few damages. Optical fibers are also unaffected by electromagnetic interference. The fiber optical cable uses the application of total internal reflection, which is also known as TIR. The fibers are designed such that they facilitate the propagation of light along with the optical fiber depending on the requirement of power and distance of transmission. The fiber optic wire carries much more information than conventional copper wire. Hmm. Here is the structure of fiber optics. The basic structure of an optical fiber consists of three parts. First is the core, second is the cladding, and third is the coating or buffer. Here you can see the glass, core, cladding, buffer, and outer jacket. So let's start with the what is glass core. It is a central tube of very thin size made up of optically transparent dielectric medium and carries the light from transmitter to receiver. The core diameter can vary from about 5 um to 100 um. So what is glass cladding? It is a optic. It is a outer optical material surrounding the core has a reflective index lower than the core. It helps to keep the light within the core throughout the phenomena of total internal reflection. So let's head to what is plastic buffer. The main function of the buffer is to protect the fiber from damage, and thousands of optical fibers are arranged in hundreds of optical cables. These bundles are protected by the cable's outer covering, which is called jacket. So what is outer jacket? Fiber optic cable jackets are available in different colors that can easily make us recognize the exact color of the cable we are dealing with. The color yellow clearly signifies a single mode cable and orange color indicates multi-mode. So there are two types of optical fiber. Depending on the number of modes of propagation, the optical fibers are classified in two types. First as single mode fiber and the multi-mode fiber. So if only one mode is transmitted through an optical fiber, then the optical fiber is known as single mode fiber. And in multi-mode fiber, if more than one mode is transmitted through an optical fiber, then the optical fiber is known as multi-mode fiber. So now let's discuss the characteristics of optical fiber. First is fiber bandwidth. It has higher bandwidth because of the speed with which data can be transmitted and the range of frequencies over which data can travel without attenuation. Second is low transmission loss. The transmission loss limits how far a signal can propagate in the fiber before the optical fiber becomes too weak to be detected. Third is dielectric waveguide. It operates in accordance with the principle known as total internal reflection. In contrast to electrical conduction, there is low loss and signals can be conveyed over considerable distances without amplification. Fourth is signal security. Fiber optic communication technology transmits data via pulses of light, which are harder to intercept than the electrical signals used by cable, internet, or the wireless signals used by satellite internet. Fifth is small size and weight. Fiber optics are lightweight and have a smaller diameter. Typically, a fiber cable weighs approximately 4 lbs per 1000 feet, while copper wiring typically weighs 39 lbs per 1000 feet. Next is operation of optical fiber. A hair-thin fiber consists of two concentric layers of high-purity silica glass, the core and the cladding, which are enclosed by a protective sheath. Core and cladding have different refractive indices, with the core having a refractive index that is slightly higher than that of the cladding. It is this difference in the refractive indices that enables the fiber to guide the light. Because of this guiding property, the fiber is also referred to as an optical waveguide. Next are the advantages of optical fiber. First is wavelength. The three main wavelengths used for fiber optic transmission are 850, 1300, and 1550 nanometers. These wavelengths are used in fiber optics because they have the lowest attenuation of the fiber. The length of a wave has a direct relationship with its attenuation rate. The longer the wave, the less attenuation. Next is frequency. The information carrying capacity of a transmitted system is directly proportional to the carrier frequency of the transmitted signals. The optical carrier frequency is in the range 10p13 to 10p15 Hz, while the radio wave frequency is about 10p6 Hz and the microwave frequency is about 10p10 Hz. Next is windows. Optical windows are flat, optically transparent plates that are typically designed to maximize transmission in a specified wavelength range while minimizing reflection and absorption. They are often used to protect optical systems and electronic sensors from an outside environment. Next two advantages of optical fiber are attenuation and dispersion. Attenuation is the reduction in power of the light signal as it is transmitted. Attenuation is caused by passive media components such as cable splices, and connectors. Dispersion is the spreading of light pulse as it travels down the length of an optical fiber. Dispersion limits the bandwidth of or information carrying capacity of a fiber. The bit rates must be low enough to ensure that pulses are further apart and therefore the greater dispersion can be tolerated. Hmm. Next are the disadvantages of optical fiber. It is high investment cost, need for more expensive optical transmitters and receivers, more difficult and expensive to splice than wires. Its price is high, fragility, affected by chemicals, and requires special skills. Next is the working principle of optical fiber. So its working principle is total internal reflection. When a ray of light travels from a denser medium to a rare medium, such that the angle of incidence is greater than the critical angle, the ray reflects back into the same medium. This phenomena is called total internal reflection. In the optical fiber, the ray undergo total number of reflections until it emerges out of the other end of the fiber, even if the fiber is bent. So, light getting in at one end undergoes repeated total internal reflection and emerges at the other end. Notice that the light reflects towards the normal as it enters the optical fiber. Notice what happens when the light hits the end of the fiber. The angle of incidence is now less than the critical angle, and the light reflects away from the normal into the air. Optical fiber work when the fiber is bent. Next is optical fiber communication. Optical fiber can be used as a medium for telecommunication and networking because it is flexible and can be bundled as cables. It is especially advantageous for long distance communications because light propagates through the fiber with little attenuation compared to electrical cables. This allows long distances to be spanned with few repeaters. Basically, fiber optic communication is a method of transmitting information from one place to another by sending pulses of infrared light through an optical fiber. This light is a form of carrier wave that is modulated to carry information. So that's it. Thank you for your patience listening. If you find this video useful,